This is part 3 of my solution to our first formative assessment, which was about evaluating algebraic expressions. And I'm going to skip down to the third and final problem for this. And just make a note, this is a challenging problem. And there's a lot of things in here that we haven't really explicitly introduced in the class and practiced. And some of these things may be more or less familiar to you depending on your math history. But I want you to be pushed on these assessments. So hopefully you can see some stuff in the first two questions that you're really comfortable with, and you're really demonstrating your ability to evaluate these types of expressions. And then you're left with something that's a little more challenging that forces you to think about some things that maybe you haven't seen in a while, that are generally considered hard, like working with fractions or radicals. You know, if you didn't get this problem on the first assessment, that's fine. But remember, we really want to have a whole collection of problems from the relatively simple to the very difficult. And so this would be an example of kind of a difficult problem that we're trying to pursue here. But it's really the same steps anyway. I'm going to begin with my substitution. I have values for the m, the n, and the p, so let me just plug them in. And you know, it can get a little tricky when we're working with fractions. But we can begin by just plugging them in just like this. So I hope you can see that m is equal to 1/2, n is equal to 1/3, and p is equal to 1/4. And there, it's just substitution so far. So again, I can work with each of these terms independently. None of the addition and subtraction is grouped together. So I can just figure out what the value of this term, and this term, kind of independently. So I'll just take them one at a time. Now, 1 divided by 1/2, I like to think about that conceptually. How many halves are there in 1? And the answer is 2 halves. And if you love your algorithms, then that's the same thing as multiplying this 1 by the reciprocal of this. And the reciprocal of 1/2 is just 2. So I'm going to simplify that by just doing 1 divided by 1/2 is 2. There are 2 halves in 1. The next term in my expression, this is a division happening right here, but I need to do this exponentiation before I can engage in this division. So in order to do that, when you square a number, really you just multiply it by itself. And if you think about 1/3 times 1/3, multiplying fractions is pretty simple. You just multiply the numerators and then multiply the denominators. So in this case, I end up with a 1/9 on the bottom of this fraction. And another way of thinking about it too is you can square the numerator and square the denominator. You square 1, you get 1. You square 3, you get 9. So that's just a different way of thinking about how we square this fraction. And then in the same way that you can square the top and square the bottom, when you're taking the square root of a fraction, that's the same as taking the square root of the top and the square root of the bottom. And I'll spare you the details about why this is allowed, but either way, the square root of 1/4 is just going to be the square root of 1 divided by the square root of 4, which is 1/2. Another way to think about it is you know, what do you square to make a quarter? You square 1/2. If I square this number by multiplying it by itself, I get 1 times 1 on the top is 1. 2 times 2 on the bottom, that's 4. So 1/2 squared is a quarter. And so the square root of a quarter is 1/2. And if you're not following all that stuff, that's okay. You can watch the video again. Hook me up with another view. So here we are. I want to do something with this middle term a little bit before I continue with my addition and my subtraction. We're actually going to do this division. And the question is, how many ninths are there in 1? That's very much like the question we answered here. It's just 9. So this becomes 2 plus 9 minus 1/2. So that's the same as multiplying by the reciprocal, right? 1/9, take the reciprocal of that, you get 9 multiplied by 1, there's your 9. So you can use your algorithm if you remember that, but also think about it conceptually. If you have a whole, that's 1, how many ninths are there in 1? There's got to be 9 ninths. So now we just have to add and then subtract. We're going to add and subtract from left to right. So 2 plus 9, that's 11. And we're going to subtract a half. And this becomes 10 and a half. Just like that.